Hi everyone, in today's video I'm explaining about preparation methods of alkenes. So how alkenes are prepared by the different reactions. Okay, let us see first reaction, that is dehydration of alcohols. So firstly I am taking alcohol. Any alcohol undergoes dehydration, that means removal of water molecule to produce a alkene. So firstly I am taking ethanol. So ethanol I am reacting it with the sulfuric acid, which is acting as a dehydrating agent. This reaction requires 170 to 190 degrees Celsius temperature. Okay, so whenever I am adding this both, there is a removal of water molecule from this. Okay, so whenever I am removing hydrogen in the form of H plus, OH minus, okay, OH minus is coming out, both reacting and forming H2O. Here there is a formation of double bond. Okay, so finally ethylene is formed from ethanol. You can take any alkene and you can do this reaction. That is a dehydration of alcohol. Next, let us see by dehydrohalogenation of alkyl halides. Dehydrohalogenation means you remove both hydrogen and halogen from the same compound. So you can see I am taking ethyl bromide. This ethyl bromide is reacting with alcoholic KOH, that is alcoholic potassium hydroxide, to produce ethylene. Along with this you are getting a byproducts potassium bromide and water molecule. You can see here KOH can break into K plus and OH minus. Okay, this K plus reacts with this Br minus and comes out as a KBr. This OH minus reacts with this H plus and comes out as a H2O. So from this both hydrogen and bromide are removed. Next you will get the double bond between these two carbons, and finally you got ethylene as a product. Ethylene is formed from ethyl bromide by the process of dehydrohalogenation. See the next method of preparation, that is from vicinal dihalides. So we are preparing alkene from vicinal dihalide. So you can observe this 1,2-dibromopropane. Here the two carbons are there. On these two carbons, the bromine atoms are present. So if bromine halogen atoms are present side by side, we call that as a vicinal dihalide. So I am taking 1,2-dibromopropane. This 1,2-dibromopropane on reacting with alcoholic zinc, on heating, we are getting the propene as a product. Along with this zinc reacting with these two bromine atoms and coming out as a zinc bromide. This reaction is a dehalogenation. Dehalogenation means removal of two halogens taking place. We call this as a dehalogenation process. So next let us see the next one, that is from alkynes. From alkynes, through the reduction process we can prepare alkenes as a product. Now we are taking the butane. I am taking the butane. I am adding a palladium and a barium sulfate in the solvent called quinoline. So this is a Lindlar's catalyst. So whenever you are adding this catalyst, we are getting the cis-butene as a product. So that means this one pi bond undergoes reduction. On addition, there are two hydrogens are added in this particular compound. There are two hydrogens are added through the reduction process. You can see two hydrogens are added on the same side. So we call this as a cis-butene. So next let us see the trans-butane formation. So butane I am taking, again I am adding a sodium and liquid ammonia. So this is a process called Birch Reduction. Okay, sodium and liquid ammonia, whenever you are adding this, we are getting the trans alkene. The hydrogens are added in the opposite way. Okay, hydrogens are present in the opposite direction. So we can call this as a trans-butane. So we are getting butane, we are getting alkenes from alkynes through the reduction process. Okay, so this is completely about preparation methods of alkenes. Thank you so much for watching.